military weapons. The BM-30 Smerch, or 9A522 Smerch M, is a Soviet heavy multiple rocket launcher. The system is designed to defeat personnel, armored and soft-skinned targets in concentration areas, artillery batteries, command posts, and ammunition depots. It was created in the early 1980s and entered service in the Soviet Army in 1989. When first observed by the West in 1983, it received the code MRL 280mm M1983. It is expected to be superseded by the 9A52-4 Tornado. Its specifications include a weight of 43.7 tons, a length of 12 meters, a width of 3.05 meters, a height of 3.05 meters, a crew of 3, a caliber of 300 millimeters, 12 barrels, a maximum firing range of 90 kilometers, and a main armament of 9M55 or 9M528 rockets. Its engine is a V12 diesel D12A 525A with 8x8 wheeled suspension and an operational range of 850 kilometers with a speed of 60 kilometers. The first confirmed combat uses of the Smerch were in 2 war zones in 2014. Syrian military forces used the system against rebel forces in 2014 during the Syrian civil war. It was also used by the Ukrainian government forces to deliver explosive and cluster munitions to Donetsk and Lugansk cities during the war in Donbas. Several have been seen in use by pro-Russian rebels, and the Russian ground forces used the BM-30 in Syria in October of 2015 during the Russian intervention in Syria. The main components of the RSZO 9K58 Smerch system are the following. Its rockets are 9M55 or 9M528, its BM-9A52-2 launch vehicle, a TZM 9234-2 transloader with an 850 kilogram crane, and 12 spare rockets. It has automated fire control equipment in the command post with a 1K123 Vivery. Its maintenance vehicle is the PM-270 MTOV with a set of arsenal equipment that includes 9F819 and its training facilities 9F827 and 9F840. The 300mm rockets have a firing range of 70 to 90 kilometers, and various warheads have been developed for the Smerch MLR-5. The NA52-2 vehicle with automated system ensures that delivery of fire from an unsurveyed position, laying of the launch tube cluster with the crew staying in the cabin and without using aiming points, autonomous determination with an azimuth of the launch tube cluster's longitudinal axis, and a visual representation of graphical information for the launch tube cluster laying, the route of the vehicle movement, and the location, as well as a point of destination and direction of movement on the video terminal. Thanks for watching, and be sure to subscribe for more videos like this one in the future.